Welcome to Service Vedic Academy. Today we are going to see how we can find an inverse of a matrix using adjoint method. Here we have to use an important formula A inverse, which is equal to 1 by determinant of A into adjoint of A. Here in the first step, we have to find the determinant of A first. If you find the determinant of A, we can arrive at two cases. If it is equal to 0, we can say that it is a singular matrix, and here inverse does not exist and we can end the sum. If determinant of A is not equal to 0, we can call this matrix as non-singular matrix. At this case, inverse exists. Then we can go for the next step. In step 2, we have to find the minors of A. Just we are converting the matrix into minor matrix. Here in A, each Aij is nothing but the determinant obtained by deleting the ith row and the jth column. Let me explain it further with an example. In step 3, we have to find the cofactors of A. Cofactors of A is nothing but adding a sign. Here I am giving a sign checker. If you add this sign to the minor matrix, it becomes a cofactor matrix. Then if you want to find the adjoint of A, means just if you want to transpose the cofactor matrix, and then we can find the adjoint of A. Transpose is nothing but interchanging or swapping rows and columns. Next, finally, the step 5, which is nothing but the inverse of A. We have to apply substitute the determinant of A and the adjoint of A in the formula. We can get the inverse of the matrix. Let me explain it with an example. Here is a question. Find the inverse of 2, 3, 4, 3, 2, 1, 1, 1 and minus 2. Here what is the step 1? In step 1, we have to find the determinant of A. Suppose we take this matrix as A, we have to find the determinant of A. In determinant of A also, we have to follow a steps and use a formula. This is the determinant of matrix formula. If it is a 2 cross 2 matrix, we can find the determinant of matrix just by multiplying the diagonals and subtract them. Here it is the determinant of A is nothing but if you multiply the diagonal A11 and A22 subtracted by the cross diagonal of diagonal elements A12 and A21. So cross multiply and subtract is the rule here. If it is a 3 cross 3 matrix, you have to first find the minors of the first row. So we have to take the first row. Here see the determinant of E is nothing but A11, the first element of the first row, minor of that element, minus second element of the first row, minor of that element. Then A13, third element of the first row and the minor of that element. Minus is nothing but deleting the corresponding row and column. See here, for A11, if we delete the corresponding row and column and find the determinant of the remaining things, we can get the minor of A11. What are all the remaining things here? A22, A23, A32 and A33. Likewise, you have to find all minors of all the elements of the first row and collect all the minors. If you substitute it in the formula, you can get the determinant easily. We can solve this sum with the help of this determinant formula. See here, we have to take the first row, first element and the determinant of minor of that first element. What is the minor of that first element? To omit that corresponding row and the corresponding column. What is the remaining elements here? 2, 1, 1, minus 2. Then you have to take the second element of the first row, but you have to put a sign minus here. See the formula here, you have to, in the second element you have to put the sign minus. So minus 3, and you have to omit the corresponding row and the corresponding column of that element. What is the remaining elements here? 3, 1, 1 and minus 2. Next what we have to do is we have to write the third element of the first row and omitting the corresponding column and the corresponding row, write the remaining inside the determinant. So this is the way you can find the determinant of the matrix. So here, what is the 2 cross 2 matrix determinant? How to cross multiply and subtract. Here likewise you have to cross multiply this, which is nothing but 2 times minus 2 minus this means 1 times 1. Here also minus 3 into 3 times minus 2. Always put the subtraction element inside a bracket, minus 1 times 1 plus 4 into 3 times 1. You have to cross multiply and subtract. Okay, what is the final answer we are getting? 2 times 2 is minus 4, 1 times 1 is minus 1, minus 3 times minus 2 is minus 6, minus 1 times 1 is 1, plus 4 times 3 times 1 is 3 and 2 times 1 is 2. Then we have to follow the BODMAS rule here. Here, what is minus 4 and minus 1? This is not multiplication, this is nothing but addition and subtraction. Minus 4 minus 1, which is nothing but minus 5. Here minus 3 times minus 1 minus 6, which becomes minus 7, plus 4 times 3 minus 2 is 1. Finally what we can get as 2 times minus 5. This is multiplication. So plus into minus, it becomes minus. 2 times 5 is 10. Here minus into minus, which is plus. So 3 times 7 is 21. 4 into 1 is 4. Here I have explained you the multiplication of the signs. Plus into plus, which is plus. Plus into minus, which is minus. Minus into plus, which is minus. And minus into minus, which is plus. You have to use this rule for multiplication of two symbols. So finally what we can get as 21 plus 4 is 25 minus 10 is 15. So which is the determinant of A, which is equal to 15. Immediately what you have to check after finding the determinant of A, you have to check whether it is a singular or non-singular. Here what case arises here? Determinant of A is not equal to 0. So we can say that A is non-singular. See here, A is non-singular. Then immediately you have to decide that A inverse exists. So we can go for step 2. What is step 2? In step 2, we have to find the minus of A. So for each and every element of the matrix, we have to find the minus. See the matrix, which is nothing but 2, 3, 4, 3, 2, 1, 1, 1 and minus 2. In step 2, we have to find the minus here. Minus of A. So if you want to find the minus of A, we can do it in the second 2, 3, 4, 3, 2, 1, 1, 1 minus 2, which is A. If you want to find the minus of A, this is nothing but step 2. Just you have to put a big matrix symbol here. So for this element, if you want to find the minor, just you have to omit this corresponding row and corresponding column and put the determinant of the remaining things. 2, 1 and 1 minus 2. Likewise, for the second element, you have to omit the corresponding column and the corresponding row. What is the remaining elements here? 3, 1, 1 minus 2. What is the third element's minor? You have to omit the corresponding row and the corresponding column. So you have to corresponding row and corresponding column means what is the remaining elements? 3, 2, 1 and 1. Likewise, if you want to find the minor of this second row element, 3 means you have to omit this corresponding row and this corresponding column. Write the remaining elements inside a determinant. Likewise, we can write all the minors here, which is nothing but 2, 4, 1 minus 2, and here 2, 3, 1, 1, and here it is 3, 4, 2, 1. Here it is 2, 4, 3, 1. If you want to find the minor of this element means just you have to omit the corresponding column and the corresponding row. What are all the remaining elements here? 2, 3, 3, 2. Okay, we can find the minors of this A. Just we have to calculate this. If you want to calculate, just you have to calculate the determinants. Here, what is the 2 cross 2 determinant? Just we can refer the formula. Here it is cross multiply and subtract. So we have to cross multiply here, which is nothing but 2 times minus 2 minus 1 time 1. Here also 3 times minus 2 minus 1 time 1. Likewise 3 times 1 minus 2 times 1. Here 3 times minus 2 minus 4 times 1 and 2 times minus 2 minus 4 times 1. Here I am cross multiplying and subtracting. 2 times 1 minus 3 times 1. Here 3 times 1 minus 4 times 2. Here 2 times 1 minus 4 times 3. Here 2 times 2 minus 3 times 3. Okay, if you further reduce this matrix, what will happen here? 2 times 2 is minus 4. I have explained it earlier itself. Plus into minus is minus, minus 1 times 1 is 1. So minus 4 minus 1 is nothing but minus 5. Okay, here also minus 6 minus 1 is nothing but minus 7. Here 3 minus 2 is nothing but 1. Here minus 6 minus 4 is nothing but minus 10. Here minus 4 minus 4 is nothing but minus 8. Here 2 minus 3 is nothing but minus 1. Here 3 minus 8 is nothing but 3 minus 8 means we have opposite signs here. So you have to subtract 8 minus 3 is 5, but we have to use the highest number sign, which is minus. So here 2 minus 12. Here also there are two different symbols. So 12 minus 2 is 10. You have to use the highest number symbol, which is minus 10. Here also 2 times 2 is 4 minus 9, which is nothing but minus 1. So finally what matrix we are getting is minus 5, minus 7, 1, minus 10, minus 8, minus 1, minus 5, minus 10 and minus 5. This is nothing but the minor of A. This is the end of step 2. We have to then what is the next step to find the inverse of the matrix, which is nothing but the step 3. In step 3 we have to find the cofactor of A. Cofactors of A is just you are going to give the symbol to the matrix we have find in minor of A. So just for finding the cofactor, this is nothing but step 3. You have to include the sign. What is the sign you have to include means? Here see here plus, minus, plus, minus, plus, minus, plus, minus, plus. See in this place, place, in this place, in this place, and this place you have to include minus. If you include plus, the sign will not change. If you include this minus in these 4 places, it becomes cofactor. So if you include, see this place, and this, you have to include a minus. So it becomes minus into minus, it becomes plus. Other things you have to write as it is. So minus into minus, it becomes plus 7. Here minus into minus, it becomes plus 10. Here you have to write as it is. Minus into minus, it becomes plus 1. Minus 5 as it is. And minus into minus, it becomes plus 10. And minus 5 as it is. So here we have found the cofactor. The next step is nothing but finding the adjoint of A. Finding adjoint of A is nothing but transposing the cofactor. Transpose is nothing but interchanging rows and columns, means we have to write the row as column and the column as row. So here if you want to find the column as row and row as column, the matrix, the cofactor matrix we have got here is minus 5, 7, 1, 10, minus 8, 1, and minus 5, 10, and minus 5. If you transpose this matrix, that we can get the adjoint of A. Adjoint of A is nothing but cofactors transpose. Transpose means changing the row to column and column to row. Take the first column minus 5, write it as a row. And the second column, write it as a second row. Take the third column, write it as a third row. Just like this, we can transpose the matrix. Now we have got the adjoint of A. What is the step 5? In step 5, we have to find the A inverse. A inverse is nothing but 1 by determinant of A into adjoint of A. Already we have found the determinant of A is 15 and we have found the adjoint of A. If you write it in the formula, 1 by determinant of A into adj A, we can get the inverse of the matrix. So 1 by 15 into, you have to write the matrix as it is, minus 5, 10, minus 5, 7, minus 8, 10, 1, 1, 5. We can end the question here itself, otherwise you have to multiply this 1 by 15 to each and every term of the matrix, because it is a scalar multiplication. So if you multiply this 1 by 15 to each and every term, we can get minus 5 by 15, 10 by 15, minus 5 by 15. Likewise 7 by 15, minus 8 by 15, 10 by 15. Likewise in the third row means 1 by 15, 1 by 15 and 5 by 15. We can cancel the common factors and get the final thing as minus 1 by 3, because 1 times 5, 3 times 5. So here 2 times 5 by 3 times 5, minus 1 by 3, here 7 by 15, minus 8 by 15, 10 by 15, 1 by 15, 1 by 15 and 1 by 3, which is the final answer for A inverse. Thank you for watching my video.